Alright, in this 4.2, we only have one objective. We only need to know how to use the substitution method to help us to find the solution of the system of linear equations. So let's check the example. We have this linear equation system. Okay, so here we are talking about a substitution method. So by its name, we need to use something to substitute something else, right? So here, if we observe these two equations, we have the second equation, x is equal to y plus 2. So it's already solved for x, right? In this equation, we can treat it, it's already solved for x. So we already isolated the x. We use another variable to express x. So maybe we should use this y plus 2 to substitute x, because they are equal, right? So that's the basic idea. Because we already solved for x, then we use this y plus 2 to replace x in another equation. So we go back to another equation, the first one. This time, first we have 2x plus y, right, equals 10. But we want to substitute x by using the second equation. So this time we will not use x. We directly use y plus x to substitute x, because we already solved for x. Now we only have one variable. So we need to simplify and combine the term. We will have y is equal to 2. Okay, first we get the value of the y, but because we still need to find the value for x, we can use either equation. So we can go back to this one. X is equal to y plus 2. Because this time we already have the value of y. So x is equal to 2 plus 2. X equal to 4. Right? So we get this ordered pair 4, 2 as our solution. But remember, we're going to check the answer. So this is the pair we got. We need to check if it's the solution for the system, yes or no. So first equation, we get 2x plus y equals 10. Right? This is the first equation we're going to have. And the second one is x equal to y plus 2. We go back to the original system. Use this paired number to test. So this time x equal to 4, y equal to 2. We use 4 to replace x and 2 to replace y. To check the left side, we get 10. And the right side, we also get 10. So it's true for the first equation. Then we realize left side is x, so it's 4. And y is 2. So we check left side 4, right side is also 4. So this is also true for the second equation. Then we will say this point is the solution. Okay? So let's check. Why this one called the substitution method? Because remember, we use y plus 2 to substitute x. So first step, we need to solve for one variable. In this case, we solve for x because we already have x is equal to y plus 2. So we pick solve for x. Then we use this y plus 2, go back to another equation. Substitute x by using y plus 2. Let's check another example. So this time we have this kind of two equations. So if we observe these two equations, then we will realize maybe this time we will choose to solve for y because we already have the second equation. Y is equal to 3x. So we automatically solve for y, right? We already solve for y. So this time we're going to use 3x to substitute y in this equation. So we use this 3x to substitute y in another equation we have. So this time we have 5x, we copy down this, minus y. Remember, we will not use y anymore because we want to substitute it. So we were going to use 3x to substitute y. Then we only have one variable. We only need to solve for x now. So we have 2x equals negative 2. X is equal to negative 1. So after we have x value, we could use this equation to help us to solve for y, right? Because this time we're going to use negative 1 to replace x. So y is equal to negative 3. So negative 1, negative 3 is the ordered pair we have. So the last step, we're going to test if this pair is just the solution for the system. So we're going to test it. We write down two equations. We need to test both equations, right? So first one, we use negative 1 to replace x and negative 3 to replace y. Then we check the left side. We get negative 5 plus 3. We will get negative 2. So it's true. Left side is equal to right side. So it's true for the first equation. Let's see. Y is negative 3 here. And x is negative 1. So left side, we get negative 3. Right side, we get negative 3. So this one is also true. If both equations are true, then what's our conclusion? We will say this ordered pair, negative 1, negative 3, is the solution. Because we already tested, right? Is the solution. So we can check another one. Because the first example, we use something to substitute x because we already solved for x. And the second example, we use something to substitute y because we already solved for y. But let's check the third example. This time, we do not directly solve for any variable, right? We do not have x equal to something, y equal to something. But we still need to solve for one variable first. That's the same procedure, the same idea. We always need to solve for some variable. But which one you're going to pick, it depends on you. It depends on you. We will pick which one is more convenient. So for this case, I will pick solve for x. Okay? Because we have x plus 2y. All the y has 2, the coefficient is 2. But x, we directly have x. So we will try to use the first equation. We use one of the equation to solve for one variable, right? We pick the first equation. I pick to solve for x, so we will have this one. X is equal to 7 minus 2y. Agree? We solve for x. Now we're going to use this one, 7 minus 2y, to substitute x in another equation. So this time we're going to use this one to substitute x into another equation. That will be equation 2. So this time 2. We will not use x. Remember, we will substitute this one. Why we need to substitute? Because we want to keep only one variable and copy the remaining term. The only different part is we use this one to replace x. So for this time, we will get, so y is equal to half. Y is equal to half. Because here we will have negative 2y equals negative 1. So y is equal to 1/2. After that, we can use this y equal to half, go back to the original one or this one. Original one, maybe we just pick original one. Or you can directly pick this solve for x form. It doesn't matter. You use this one to solve for x. This time, y is equal to 1/2. So x is equal to 6. After we get the value of y, we go back to any one of the equation with 2 variables to help us to solve another variable. Okay, so our ordered up here we have is 6 1/2, but we still need to test, remember? So we test if it's true for both equation. This time we just check our answer, right? So 13. Let's try this one. 6 to replace x and 2y like this. So the left side we got 7. The right side we also get 7. So it's true. Let's check this one. 6 is x and half is y. Let me check the left side. 12 plus 1 is 13. And the right side is 13, so it's also true for the second equation. After that, we can conclude this ordered pair is just the solution. If you have time, you always need to check the answer, okay? If you have time. Of course, you can, if you want, you can always use the graph to help you check if it's the answer. But I know maybe we do not have enough time for our test to use the graph. So you can just use the equations to help us to check the answer. So we will say, after we check several examples, we can conclude the method, conclude the substitution method. It's something like step 1, we solve one variable. One variable. By using one equation. So we can pick one equation to solve one variable, but which equation you're going to pick or which variable you're going to solve, it depends on which one is more convenient for us to solve, right? And step 2, we should substitute the expression for the variable. Substitute the expression. Remember from step 1, we already solved for one variable, so we got the expression for the variable. If we solve for x, we will get x equal to some expression. Then step 2, we're going to use that expression to replace the variable x, right? But this time we're gonna substitute the expression in another equation. So if we use equation 1 to solve for x or y, then we're gonna substitute the expression in equation 2. So they cannot be the same equation. We should use one equation to solve for variable. Then use substitute method in another equation. Okay. Step 2. We already changed two variable equation to one variable equation, right? We only need to solve the one variable equation, because we substitute one of the variable. So we only have one variable. Two variable to be one variable. We only need to solve one variable. Then we use the value of one variable using the value of one variable. So that's the answer from step 3, right? From step 3, that's the answer from step 3 to get the value of another variable. So if we already know the value of y, we go back to the original two variable equation to solve for x to get the value of x. If we already know the value of x, then we go back to the equation to find the value of y. So after that, after these 4 steps, we can get the x value and the y value. So we already get the ordered pair. So the last step is just check the answer. Check the answer if it's the solution for the system. Okay, so that's the general procedure for the substitution method. So the most important part is you need to select an equation and solve for one variable. So that's the beginning part, will be the most important part. Sometimes you need to observe 2 equations you have, then pick which one is more convenient to solve. Sometimes we solve for x and sometimes we solve for y. So that's the most important part for 4.2, just the substitution method. Okay, if you have time in your test, make sure always check your solution after you get to the answer. Okay, let's check one more example maybe. So this time we want to solve this system. So we have 2 equations, right? We're gonna pick one, then solve for one. This time I'm gonna pick equation 2 to solve for x. So x for x. Okay, this is equation 2. So we pick equation 2 to solve for x. So we will get negative 4x equal to 8y. Then x is equal to negative y. x is equal to negative y, negative 2y, okay? Then we should use this expression to replace x to another equation because we already used equation 2, right? We're going to use equation 1. So this time we use this negative 2y to replace x in the first equation. Then we will write the first equation to be, again, we're going to substitute x. We use negative 2y to replace x. Now we only have one variable need to solve, right? So we will have this kind of situation. Negative 12y plus 12y equals 5. Then we will have this statement. 0 equals 5. So this one is a fourth statement, right? Because 0 is not equal to 5. Right? 0 is never equal to 5. Why we will have this kind of situation? That means we do not have solution. Because we cannot get this fourth statement, which means if we got a fourth statement, it's fourth, right? Then we can directly conclude this system has no solution. No solution. Remember, in previous section, we talked about sometimes a system has no solution. How can we know this system has no solution? Remember, if these two straight lines are parallel to each other. So if you want, you can draw the line for the both equation. You will realize you will get two parallel lines. But another quick way to check without graphing is to check the intercepts and the slope. Remember the slope-intercept form. So if you get this fourth statement, you can directly get this conclusion. No solution, but because this is the example we're going to test if it's true, right? We're going to change the equations to the slope-intercept form. So for the first one, we will have 12y equals negative 6 plus 5. So we will have y equals negative half x plus 5 over 12. So this is the equation 1. And we have equation 2. We also need to change it to the slope-intercept form. So we will get 8y equals negative 4x. And we will have this as the slope-intercept form. Then we observe these two slope-intercept forms. We know they have the same slope, right? But they have the different intercept. So same slope, different intercepts. We know these two straight lines are parallel to each other. If it's parallel to each other, there's no intersection points. No intersection points. So we get the same conclusion. No solution. Of course, if you use the substitution method to solve the system and you get this fourth statement just like this one, 0 is equal to 5, then you can quickly get the conclusion. Has no solution. Okay, we already tested. This is correct. We use the slope-intercept form method to test. We get the same conclusion. There's no solution for this kind of system because two lines are parallel to each other. Okay, So that's all for 4.2. Substitution method.